Okay, looks like it's recording. So this is chapter 4, section 1, and they're talking about powers of 10, but it's getting a little more complicated now, because now we're dealing with powers of 10, multiplying numbers by 10, by 100, by 1,000, by 10,000, that have, Miss Jennings, decimals in them, okay? But let's just do something real simple, real quick review here. I just want to show you guys something. If I said, what's 363 times 10? Hopefully everybody would know it's 363, and you would just add a 0. If I said, what's 363 times 10 squared? It's going to be 363, and then I'm going to add 2 zeros. If I said 363 times 100, because 10 squared and 100 are the same thing. It's going to be 363, add 2 zeros. Because 10 squared and 100 are the same thing. Gosh, I hope everybody knows that by now. If you don't, I don't know what to tell you. All right, you can lead a horse to water, but you can't make him drink. Next one, next example, 363 times 10 to the third power. That's 363. Add how many zeros? 3 zeros. Okay, and then you can put a comma for every third spot. Don't sharpen your pencil now, thank you. All right, 363 times 1,000. Again, that's the same thing. 10 to the third and 1,000 is the same thing. You guys should know that by now, okay? So the answer to that one would be the same. It'd be 363,000, okay? Now, if we throw a decimal in there, actually, let me do this.
Do you have to see Mason at recess, please?
Yes. The 363, this very first one that we were looking at, where's the decimal in this right here, in the 363? Where's the decimal in that? Yeah.
After the 3.
It's after the 3. That decimal, so if I wrote down 363, you guys all know the decimal's right there. Right, Miss Rieger? The decimal's right there. But now I've added a 0. So where's the decimal gone? It's moved over 1. 363, 0. The decimal's now there. I've moved the decimal one place over. All right? You guys, you're going to want to pay attention. You're going to be totally lost if you don't. So, in this one right here, in the second one I was talking about, 363, I'm going to write it down again, 363, and I multiplied that by, as you can see here, 10 squared, or you could look at it as 100. Where's the decimal in the 363? It's right here. And what did I do? I added 2 zeros, right? So it became 36,300. How many places did I move the decimal? Because the decimal is now here. I moved the decimal 2 places over. In this one, I moved the decimal 1 place. In this one, I moved it 2 places. And times 100, same thing, 2 places. Where's the decimal in this 363? It's right here, but I moved it 3 places. In 1,000, I moved it again, 3 places. So in whole numbers, like in 17, the number 17, the decimal is right behind the 7. If I multiply that by 10, I move the decimal 1 place. Now, look at these here. This is what I want you guys to understand. Here we have 3.63 times 10. I'm going to move the decimal 1 place. Now it becomes 36.3. It's the same thing. I'm just moving the decimal. 3.63 times 10 squared. Miss Gunderson, 3.63 times 10 squared. Where's the decimal going to be? Here it is right here. Where is it?
After the 6.
Times 10 squared. 2 places.
So it'll be after the 3.
After the 3. 1, 2 places. So it's 3, 6, 3. You see, I moved it 2 places because it's times 10 squared. How many places do you think I'd move it if it was something times 10 cubed? How many places would I move the decimal? 3. What if it was 10 to the 5th power? How many places? 5. What if it was 10 to the 1st? How many places? 1. What if it was just 10?
0.
No, 1. Because remember, these two are the same thing. Same thing. Don't let them trick you. They'll try to trick you that way. All right? All right, what if it was 10 to the 6th power? How many places? 6, okay. So depending on the power, or depending on the number of zeros, that's how many places you move the decimal. What if I was to multiply a number by 1,000? How many places do you move it? 3. What if I was to multiply it by 1,000,000? How many places would you move it? 6, okay. So whether it's an exponent form or whether it's a whole number, that can be divided by 10, that's how many places you would move the decimal. So let's go back to this. 3.3, this is the one I'm looking at right here. 3.63 times 100. Miss Adams, where's the decimal?
After the last 3.
Yeah, 3, 6, 3. I just moved it 2 places. 1, 2. It's right there. In a whole number, we don't bother putting down the decimal because we know it's there. Okay, Mr. Button.
If it's something like 63.6 times like 5, how would that work?
63.6 times 5. Okay, so I will teach you guys how to do that kind of problem. That's something you're actually going to learn this year. But right now, I just want you to learn how to manipulate or move decimals going by the powers of 10. So we'll have to get to that later, Mr. Button. All right, so let's look at the next one here. Okay, 363 times 10 to the 3rd power. Okay, now this one's kind of tricky. So look, we have 2 places to move it, but it's 10 to the 3rd. So it's going to be just like if it was a whole number. You know how you added zeros, how we were doing that 5 minutes ago? So I'm just going to write down 363, and I'm going to add a 0. So 3.63 times 10 to the 3rd is 3,600. I moved it 3 places. I didn't stop at the 3 because I had to add a 0. So again, same thing, 3.63 times 1,000, it's the same thing as 10 to the 3rd. So it's 3, 6, 3 zeros. Okay, I'm going to pull some sticks. I'm going to write down a couple more. I'm going to see if you guys can do these. Everybody tell me where the decimal ends up in this. Mr. Eberhardt. 3.792 times 10 squared. Where's the decimal?
In front of the 9.
Yeah, right. Well, actually, it'd be behind it. So 1, 2 places. So it becomes 379.2. He moved it 2 places. Okay. Anybody not understand this? Raise your hand because I'll give a couple more examples if you guys want me to. Yeah, Mr. Gisa. Okay.
I don't really understand it if it goes over.
If it goes over, okay. So Mr. Gisa, I'm going to do 4.2 times 10 to the 3rd power. That's supposed to be a 3. It's not a very good one. Let me try it again here. 3. There we go. Okay. So Mr. Gisa, let me ask you, how many places do you have to move the decimal? 3. But we only have 1 spot, right? So that means we're going to have to add 2 zeros. So it becomes 4200. Make sense now? Okay. So if reminding me that we have computer lab here shortly. So if there's not enough places to move it, then just start adding zeros. All right? Make sense? Okay, so hopefully you guys get that. Let's look at a couple more that I wrote down. Okay? So here we have, look at this one, 0.009 times 10. Now, are those the same thing? Look at those two. Are those the same thing? Let me pull a stick here. Miss Guerin.
Yes.
Yeah, they are, the same thing. Okay. Now, so look at this, Miss Ogisa, I'm going to pick on you because you were asking me, how many places do I move the decimal? One. So I'm just going to move it right there. So now this becomes, I could write 0.09, or I could just not even worry about that and just write 0.09. Either one would be correct. Just moving the decimal over one place. Put up 10 points. Mr. Hinkle. How many places do I move the decimal in number 4 here that I'm looking at? 2 places. Okay, so here's the decimal. I'm going to move it. Look, 1, 2. So it's between the 6 and the 2. So I'm just going to write 6.2. All right? And same thing, 6.2. All right? These are the, doesn't matter, 1, 2, whether the 0 is in front of the decimal or not, 6.2. You guys get it?
Yeah.
I hope, yes, kind of, sort of, maybe? All right. All right, so let's look at the work they've given you really quick here. I think they kind of go the long way around the barn about explaining some of these things here. But so look, here's what they're showing you. 363, this is what I'm looking at here, times 1, that's 363. And then 363 times 10 to the first, or times 10, you're adding a 0. See, the decimal was here. Okay, now it's here. They've moved it over 1, and here they've moved it over 2, and here they've moved it over 3, because it's a 3 and a 2 and a 1. And then they have a place value chart here. Here's the decimal form, 3.63 times 1, 3.63 times 10. You move the decimal one place, becomes 36. Then it becomes 363, then it becomes 3,630, okay? I think you guys get that, but maybe that kind of chart will help you. The convince me, I'd like you guys to do this. It says complete the chart. What patterns can you use to place the decimal point? So I'm going to do this first column here, and I want you guys to do the rest. So what's 1.275 times 10? Mr. Cosgrove.
12.75.
Perfect. That's beautiful. Put up 50 points. 12.75. He moved the decimal one place. Mr. Ward. 26.014. Yeah, you do. Look up here or look in your book, doesn't matter. Where's the decimal in this number, 26.014? Where's the decimal? What's it between?
6 and 0.
Yeah. So you got to move it one place to the right. Where's it going to end up?
Between the 0 and the 1.
Right. So tell me, what would it be?
No.
So you can just tell me the numbers, and then you could say decimal and the rest of the numbers if you want to do it that way. 260.14 is perfect. You knew it. Next one. Miss McGee, 0.4 times 10. Think about what we've been doing. How How many times have we been moving the decimal over in this column? What's that? One time, right. Where's the decimal right now in the 0.4? Where's the decimal? Yep. Where should it go? Behind the 4. So it becomes 4. Now you could put 4 in the decimal, but again, in whole numbers, we don't bother putting the decimals down. We just know what's there. Okay, so it just becomes 4. All right, so I want you guys to do the next 2 columns. Let's go down to the guided practice, the next page. Let's take a look at that here. Gosh, we're at 15 minutes already. I got to move this along here. When multiplying by a power of 10, I'm looking at number 1 here, like 4.58 times 10 to the third, how do you know you are moving the decimal in the correct direction? Well, when you move the decimal to the right, the number is getting larger. If you move it to the left, it's getting smaller. Let me show you what I mean. Look, if I had 45, and the decimal's right here, and I move it over 1, and now I add a 0, what's bigger? 45 or 450? What's bigger? 450. All right. If the decimal's right here and I move it to the left, I go this way, and it becomes 4.5. What's bigger, 4.5 or 45? Right, so when you go into the left, it's getting smaller. When you go into the right, it's getting bigger. And you can phrase that however you want. In fact, you could just put it the way I just said it if you want. When you move it to the right, it gets larger. When you move it to the left, it gets smaller. All right, 2 through 5. I actually did a couple of those for you already. And do those. And then I'm looking at independent practice here. You guys could do those. I'm going to look at number 7 here, the third part. It's point, you can see it here, 0.086 times 1,000. Mr. Oldham, what would that be? How many places you move the decimal? Three places, right? So where's the decimal going to end up? After the 6. So would you ever write a number like 0.86? No, you wouldn't even worry about the 0 in front. You would just put 86. I would never, is 0.86, is that a, why would you put the 0 there? You wouldn't. You would never put a 0 in front of a whole number. It doesn't mean anything. Okay? So that'd be 86. All right, and then you guys can do the rest of those on that page. Let's drop down, or go to the next page, the last page here. If I don't hurry it up, it's going to be a 20-minute video. Monroe uses a microscope to observe specimens in a science class. The microscope enlarges objects 100 times. That tells me right there it's going to be 2 decimal places. Find the size of each specimen as seen in the microscope. So in other words, you're going to be multiplying everything by 100. And then it says, Monroe's teacher wants each student to draw a sketch of the longest specimen. Which specimen is the longest? In other words, what's the largest number? 21, seen through the microscope, a specimen is 0.75 centimeters long. What is its actual length? Oh, so I'm going to help you guys with this one. This is seen through the microscope, so it's been multiplied by 100. But its actual length is going to be 0.0075. So there's your answer to that one. We've multiplied that number by 100. All right, 22, John's binoculars and large objects 10 times. Yeah, you guys can do that one. 23, Jefferson drew a line 9.5 inches long. Brittany 10 times as long. What's the difference between the two lines? This is important. They're asking you difference. What's the difference? Which means you're going to have to subtract. You're going to subtract Jefferson's line from Britain's, or Brittany, rather. Okay? Mr. Lee De La Rosa, question?
Are you gonna make one worth a stick?
Good question. I think I will. Thank you. 24, Jose ran 2.6. Pavel ran 2.60 miles. Who ran further? Explain your reasoning. Yeah, there's a stick right there. I like that one. So there's one. It's worth a stick. And you guys can do the other two at the bottom, 25 and 26. So yeah, all these, whoops. I'll ask one person about all four. They have to get all four correct. That's worth a stick. And then you won't know. I'll probably do one of these. You won't know which one. Worth a stick. Okay. 21 minutes. It's, I think, the longest one this year. Stop video recording.